Welcome to the Bentley Systems training course to learn how to design soil-supported mat foundations using RAM concept. Before we begin designing our mat foundations in RAM concept, let's first discuss some of the benefits or why you may use RAM concept for your design. RAM concept can design a wide range of structure types. This reduces the need to purchase and learn other products. RAM concept can design post-tensioned, reinforced concrete, and hybrid systems for elevated and maffed or raft foundations. They can design one-way slabs, two-way slabs, beams, and joist systems as well. Over the next series of videos, we will show you a realistic workflow for designing soil-supported mat foundations in RAM concept, which includes the process for modeling your soil springs, specifying the appropriate design span properties for a mat foundation, performing the design on your mat foundation, and then finally reviewing the results. The first step in our workflow for designing soil-supported mat foundations in RAM concept is to model your soil springs and define your soil spring properties, which will include the elevation above the slab soffit, your spring angle or the orientation of the local axis, your R force, S force, and Z force constants, and these are your spring constants in the direction of the local R, S, and Z axes, and also your R and your S moment constants, which will be your angular spring constants about the local S or R axis at each end. Area springs will be modeled on the mesh input layer using the area spring command. To begin modeling the soil springs, we will now open up our sample mat foundation model and navigate to the Mesh Input Standard Plan. To do this, we will go up to our Layers menu, select Mesh Input, followed by Standard Plan. Now for this training course today, we are going to be modeling a mat foundation using several pieces of information that have already been created in RAM concept, including all of the walls, the slabs, and the concrete columns that have already been created. At this point, we are ready to start modeling the soil springs. Our first step in doing this is to specify your soil spring properties. So over in your layer-specific toolbar over at the right-hand side of your screen, we will now double-click on the area spring icon. Here we can specify all of the information, including the elevation above the slab soffit and the R, S, and Z force constants. And here we'll leave all of these set to their defaults. After you are done entering your default area spring properties, we'll go ahead and click OK, and we are ready to start modeling the soil spring. Here I will go ahead and click anywhere outside the slab in the lower left-hand corner, and then I'll just continue clicking around on the outside of the slab, and RAM Concept will automatically trim the soil spring to the extent of your slab. So go ahead and create a closed polygon, and here I can see my soil spring has been modeled. The second step for designing our mat foundations in RAM concepts is to specify the appropriate span design properties for a mat foundation. The design span properties for mat foundations are similar for those for a standard reinforced concrete slab, except for the code minimum reinforcement location, which is found in the column strip tab. Here you should set this option to mat foundation. The code minimum reinforcement location indicates the minimum tensile reinforcement code rules to consider for flexural stress conditions. They determine the minimum reinforcement based solely on geometry and the expected tensile forces. And when this option is set to mat foundation, the minimum reinforcement at a column will be located at the bottom face of the slab. To specify the design span properties, we must first navigate to the design spans plans. And we'll start with the latitude plan for this exercise. We will go up to the menu bar and select Layers, followed by Design Strip, followed by Latitude Design Spans Plan. Here you can see all of the design spans have already been set up for a traditional reinforced concrete slab, and all we have to do is modify the properties for a mat foundation. With our selection icon active, we will now draw a fence around the entire slab to select all of the design spans. We will then right-click and select Selection Properties. Here we will select the Column Strip tab in the Selected Items Edit dialog. Down here where it says Code Minimum Reinforcement Location, we'll ensure that that says Matte Foundation. And then we'll click OK. We will now repeat this process in the longitude direction. So we'll go back up to our Layers menu bar item, select Design Strip, followed by Longitude Design Spans Plan. With our selection icon turned on, we will now select all of the design spans in the longitude direction, right-click, and select Selection Properties from the pop-up menu. Once in the Edit Selected Items dialog, we will select our Column Strip tab and ensure that our Code Minimum Reinforcement Location is set to Matte Foundation. And then we will go ahead and click OK. After you have entered all of your design properties appropriately, you should regenerate your design strips. This can be done through your standard toolbar by selecting the Generate Strips icon. RAM Concept will regenerate your strips in both directions, and then of course before performing the design you should also regenerate your finite element system. To do that, you can return to your standard toolbar and click on your Generate Mesh icon. Here we will select an element size of 3 feet and then go ahead and click Generate. At this point, our structure is completely modeled through our Mesh Input Standard Plan, and our design strips are set appropriately for a matte foundation. For this sample model, we have also modeled all of our loadings on the appropriate loading layers, and at this point, we are ready to go ahead and perform the design.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.